Let us take some of these instances. Look at this instance here. This is two basketball players. They are trying to get hold of this ball and they want to basket it. All right. And the second situation is here is an ox which is pulling this bullock cart. And we have this battery. Look at this. This is a battery which is trying to glow a bulb. Okay. Because of this battery only this bulb is glowing. What do you think these three situations have in common? If you think for it, the answer is energy. All right. So, what is this energy? The simple definition for energy is a capacity to do work. Capacity to do work is called energy. That's it. Very simple definition. Now look at this. Look at this ox. When you have a look at this ox is able to pull this cart because of the energy only. No, because of energy only it is able to pull this. These two players they are trying to get hold of this ball and they make use of their energy. They have eaten food and they are getting use of that energy to get hold of this ball. Now look at this battery. You must have charged it. No, you must have charged it before. You must have provided energy for that. By using that energy only, this battery is trying to glow this bulb. So the simple definition for energy is capacity to do work. All right. Now, what are the different forms of energy? We have different forms of energy, right? Look at this situation here. This lady, she is trying to lift this weight, right? This weight lifting, whatever this weight lifting is happening here. So this is possible because of energy only, no? So what kind of energy this lady has? Don't you think it is muscular energy? Don't you think in her body there are so many muscles and they have got energy, and why this muscular energy is there? Definitely she must have eaten food. Because of food she must have got muscular energy that is there. Food is again what kind of energy it is? It is you can call it as bioenergy. Okay, biochemical energy also you can call it. All right. So like that there are different forms of energy. One is predominant is muscular energy. Our bodies have muscles and they have got energy. That is one kind of energy. Now look at this situation. Here what do you infer from this all these things? Look at this. There are some panels here, no? So these are called as solar panels. What is the name for this? The name for this is a solar panel. All right. So on solar panel, when sunlight falls on solar panel, they are able to make some energy out of this. They convert that solar energy into electrical energy. So one type of energy is solar energy. Okay. And one more thing you can see here. Here also you can see these wind fans here. So don't you think wind energy is also one type of energy? Because of that wind energy, these blades are there, no? These fans are there. They are rotating. They are rotating means rotating. The energy due to rotation is called kinetic energy. That's what today's discussion is all about. All right. Kinetic energy is due to motion. All right. Because of this wind energy, kinetic energy comes and they rotate, and that can be converted into, afterwards that is converted into electric energy. That's a different issue. We'll discuss that. Conversion of energy from one form to another form, we'll discuss it in law of conservation of energy. As of now, we have solar energy, we have wind energy, kinetic energy, electric energy in this situation. All right. Moving forward, look at this. Here there is a utensil. We are heating it. Don't you think it is thermal energy? Thermal energy. When you say thermal energy, it is something related to heat, right? Something related to heat. You can also call it as heat energy. Yes. Now we have one more situation here. Look at this. This is sun. Sun is there. From sun we are receiving this energy, right? So we are receiving the energy in the form of light, in the form of heat. All right. So this is an example for solar energy. This is not example. This is a solar energy. All right. So solar energy is known as primary source of energy for us. What is this? Solar energy is primary source of energy. Because of this solar energy only other sources of energy are possible. All right. This is the primary source. This is the first and foremost energy what we receive to our earth. Okay. So that's why that is known as primary source of energy. All right, moving forward, look at this. I mean, these are the lines, transmission lines from this electric tower. So this is electric energy, very very I mean important part of modern life. Without this electricity we can't do anything. Yes or no? So that's why this is electrical energy is also known as modern source of energy. This is also known as what? Modern source of energy. Because of this only we are able to produce heat, we are able to do work. Okay, so many things are there because of this electric energy. All right. Now look at this. I mean here other types of energies are also there. Now when you are observing this bow, look at this. Okay, this is arrow and bow, right? This is arrow and bow. So before releasing this arrow, I mean this archer will be pulling this bow, right? I mean this thread, I mean in this some energy is stored, right? Some energy is stored. When he releases the arrow will be moving forward. When the arrow moves forward, definitely it has kinetic energy. When the arrow is moving forward, it has kinetic energy, there is no doubt in that. But there must be some energy in this string, I mean due to that elasticity. So that energy is called as elastic potential energy. What is the name of that? Elastic potential energy. I will come to potential energy definition. Okay, elastic potential energy. For time being, you understand, due to this elastic potential energy, whatever this elastic potential energy is there, so due to that elastic potential energy, I mean this arrow will go forward by gaining the kinetic energy. All right, that much you can remember for time being. Now moving forward, look at this boy. This boy is standing on I mean height of 3 meter. Now when he is standing on a height of 3 meter, definitely he must be having some energy, that is only known as potential energy. Potential energy means energy of a body due to the position. Now he got some position here, no, so that's why he got some energy, that is potential energy. We'll come to that. All right. Now look at this spring. If you observe this spring here, I mean due to the gravitational pull of this body, whatever this body is there, it is coming down, that is for sure, there is no doubt in that. Then why it is going above? That this is going above due to elasticity. Okay, you can call it as elastic potential energy, or you can also call it as spring potential energy. Okay, both are okay. Elastic potential energy or spring potential energy, both are same. I mean you can call them with these names. All right, so it is coming down due to the mass and it is going up, so there must be some energy in this spring. All right, now look at this boy. So this boy is jumping from this place to this place, means he must be having some velocity. All right, so if he is having some velocity, means he must be having certain kind of energy. That kind of energy is known as kinetic energy. That is known as what? Kinetic energy. All right, so majorly I am talking about potential energy and kinetic energy in 9th standard, and afterwards when we move forward into 10th and 11th standard, we will be studying about different kinds of energies. All right, fine then. And now look at this. I mean here in the syntax, in this syntax we have stored water, right? We have pumped the water from the motor. In the syntax the water is stored, and whenever we need, that water can come down just like that through the tap. Again we there is no need to use the motor there. All right, so what kind of energy is there in the syntax? This water has potential energy, again due to the height, due to some position, this is having energy, right? That's why potential energy. I have given you one example here, no, at the back also. This boy is at some height, he is having potential energy. Due to the position, if any body is gaining any energy, means that is potential energy. And due to motion, if a body is gaining some energy, that is kinetic energy. All right, so there is one more example. Look at this. This is spring. I have already explained what happens there. Whenever a hump comes, right? So whenever a hump is coming, so I mean due to this pressure of this seat, what happens here? This spring will go down, right? And it stores some energy, and again it bounces back, so that the seat comes back to the original position, and you will have a smooth ride. All right, you will have a smooth ride. That's why this spring is given. That is also one kind of energy, that is spring energy. Already I have talked about that. Now by discussing all these things, we are coming to one important definition, that is known as mechanical energy. About this mechanical energy we will be studying in 9th standard. Alright, this is the main discussion for us. Now, what is this mechanical energy? Mechanical energy is nothing but, the energy of a body due to its motion, position or configuration is called mechanical energy. Alright, these are the three things. These are the three words which you have to concentrate. What are those? One is energy due to motion, another is energy due to position, another is energy due to configuration. Now let us see the examples. Okay, so what is the energy due to motion? You have seen, right? Motion means those basketball players, they were moving, right? So basketball players, they were having the muscular energy, and they were moving, and about that ox pulling the cart, so that was also due to motion. The boy was jumping from one tower to another tower, he was moving, moving boy, moving boy. So these are all the examples for what? This is the example for energy due to motion. Now how about this energy due to position? Position is due to, water in syntax, that was due to position. Okay, and a boy on top of a tower, boy on top of a tower, so his energy was due to position only. Alright, now how about configuration? You have seen that bow and arrow, right? In bow and arrow, what happens? That was due to some configuration, no? He pulled it, that's why it got the energy, that is due to configuration. And how about spring? That spring is also due to configuration. So in spring and all, you must have seen some toys made up of springs, no? So those get energy due to this configuration. Alright, so these if the body is getting energy due to these three things, means motion, position and configuration, that type of energy is called as what? Mechanical energy, something related to motion and position and configuration. Alright, now there are two types of mechanical energy. The first type of mechanical energy is potential energy. Okay, potential energy. And what is potential energy? Potential energy means the energy of a body, energy of a body due to its due to its due to its position, due to its position or configuration, position or configuration. We will come to this potential energy in the next video. Our main discussion is about kinetic energy. Alright, our discussion is about kinetic energy. What is this kinetic energy? We'll see this in the next slide. So what is this kinetic energy? Tell me now. The kinetic energy is nothing but the energy of a body due to its motion is called kinetic energy. Alright, for example, let me give you the formula. There is a body here, there is a body of mass m, and it is moving with velocity v, for example. Alright, so what is the formula for its kinetic energy? Its kinetic energy is equal to half mv square. That's it. Alright, this is the formula. How this formula came into existence? Let us see that. For example, there is a body here of mass m, and it is having velocity of 0. That means it is at rest. Alright, now what happens? You applied some force on it. You applied some force on it for some time, and it moved here, it has come to here, and it has covered displacement of s, and now definitely you have applied some force, means it must be moving with some velocity v. Alright, now initial velocity was 0 and final velocity is v, and some displacement has happened and velocity has increased, means there must be some acceleration. If you take this 2as is equal to v square minus u square, look at this, what it becomes? It becomes 2as is equal to v square minus u square is nothing but 0 square. Alright, then we will have 2as is equal to v square, and if you take s is equal to what it becomes? It becomes v square divided by 2a. Alright, now afterwards, what is the formula for this work? Work is nothing but a force into displacement. Now what is this force? Force is nothing but mass into acceleration. And what is this displacement? This displacement is v square divided by 2a. Just now we got it, no? Look here, displacement is v square divided by 2a, and this a and a get cancelled. What is the formula for this work? This work is nothing but half mv square. So this is a work what we have got. Now what is this work? Whatever work you have done, that work has only converted into energy here, no? That work has converted into kinetic energy of this body. Are you getting my point? So this work can be made equal to what? Kinetic energy. So that's why kinetic energy is equal to, what is the formula? Half mv square. All right, initially only I have told you the formula and I have shown you the derivation how to do that. So whatever this work is done, that is only converted into kinetic energy, because work and energy are interchangeable. I mean, if you have energy, you can do the work, and if you are doing the work means you have energy, you have given some energy to the body. That is the meaning of it. All right, these are vice versa, these can be interchangeably used, work and energy. Now what is the unit of work? The unit of work is also joule. And what is the unit of energy? The unit of energy is also joule. So these are interchangeable, interchangeably they can be used. You will get to know about that as we proceed. All right, so fine, then let us take some numericals on kinetic energy. A body of mass 10 kg, so mass of the body is 10 kg, is moving with a velocity of 36 km per hour. So velocity of the body is equal to, how much is that velocity? 36 km per hour, but we have to convert this into meter per second. Now how to convert this into meter per second? That is 36 into 5 by 18. Now what is this 5 by 18 means? You have to go back to the motion video and you have to look that, you have to watch them, then you have to come back so that you have complete detailing. All right, so 18 ones are 18 twos are, so 2 into 5 is 10, so it becomes 10 meter per second. Fine, velocity of this body. Now kinetic energy they are asking. Kinetic energy is equal to, what is the formula? Kinetic energy is equal to 1 by 2 mv square. So that is 1 by 2 into m is 10 into v square is 10 square. All right, 2 ones are 2 fives are, and it becomes 5 into 10 square is 100. So totally it becomes 500 joule. So this is the kinetic energy of this body. All right, so let us move to next question. The velocity of a body is doubled. Okay, velocity from v it has become 2v, doubled. The kinetic energy of the body, I mean, they have given 4 options: doubles, remains the same, increases by 4 times, decreases by 4 times. All right, let us take a body which was moving with velocity v, for example, and mass of this body is m. Okay, so mass of the body is taken to be m. Now if you take its kinetic energy, what will be its kinetic energy? So let me call it as k. Okay, so it is half mv square. So this is the kinetic energy. Now here is the body. Now its mass do not change, mass will remain same, m only. Let us take its velocity has become 2v. Why 2v? Because they are saying the velocity of the body is doubled. Now what will be the kinetic energy? Definitely it will have new kinetic energy. Let me call it as k dash. All right, so k dash is equal to half m into, instead of v square, what we have to write now? We have to write 2v whole square. Now what it becomes? It becomes 1 by 2 into m into 4v square. All right, let us take this 4 at the starting. 4 into, it becomes half mv square. All right, so 4 into half mv square means what? Half mv square means this is initial kinetic energy. Look at this initial kinetic energy. So k dash is equal to what we got now? 4k. That means the whatever kinetic energy is there now, that is 4 times of the initial kinetic energy. That means it becomes 4 times, it increases by 4 times. That's why this option becomes correct. All right, so these kind of questions are very, very important, and you should be able to answer them in this way whenever those kind of questions are asked. All right, now moving forward, what is the relation between this kinetic energy and work? Already I have told you, I mean, work and kinetic energy are linked with each other, but let us try to get some more good relationship here so that it helps you in doing the numericals. Let us take this body of mass m which was moving with velocity u, for example. It was moving with velocity u. Now if you apply the force, what will happen? Definitely, its velocity will increase, right? So its velocity has become v, for example, and it has covered displacement s in this time period. All right, now this time this velocity, initial velocity, is not 0. Just to derive the expression for kinetic energy, I have taken that as 0, but now it was having some velocity. Now on applying force, its velocity has become v, covering the displacement s. Now if you apply the relation, that is 2as is equal to v square minus u square. Now what will be the formula for this s? This s is nothing but v square minus u square divided by 2a. All right, now what is the formula for work done? Work done is equal to force into displacement. All right, now work is equal to, force means what? Force means mass into acceleration. into displacement means, look at this, I mean let me call it as equation number 1. Displacement means it becomes a v square minus u square divided by 2a. v square minus u square, v square minus u square divided by 2a, and you can write it from 1, I mean from equation number 1 we have written this. Now if you write work is equal to, here this a and a get cancelled, now what remains there, m remains, in the bracket you write v square minus u square then divided by 2. Alright, so work is equal to what it becomes, it becomes mv square minus mu square divided by 2. Now if you write it separately, work is equal to, it becomes 1 by 2 mv square minus 1 by 2 mu square. Now if this u was 0 means this entire term would have become 0 and we would have left with only half mv square. Now this is not 0, right? Now if you write it, what is this half mv square means, don't you think it is final kinetic energy? Because this is a final velocity means it must be getting some final kinetic energy. This is the initial velocity means it must be getting some initial kinetic energy. So that's why you can directly write this is final kinetic energy minus initial kinetic energy. Are you understanding my point? Work done on a body is equal to final kinetic energy minus initial kinetic energy. Now if they are asking you how much work is done, no need to worry about force, no need to worry about displacement. You can directly write work done is equal to final kinetic energy, that is half mv square, minus initial kinetic energy, that is half mu square. Alright, so whatever this work done is there, that is a difference of these two kinetic energies. So that's why we can directly write work done on a body, work done is equal to change in kinetic energy. Change in kinetic energy, very very important relationship for the numericals. Whenever numericals are asked, you can definitely do that. Alright, I hope the concept is quite clear. Now observe this, no, I mean when you observe this you will get to know that, I mean if you're doing more work, for example there is a body here, okay, there is a body here, if you apply more force and if you're doing more work means on this body, if you do more work, if you push it very hard means, I mean don't you think its velocity will increase more? If its velocity is increasing more means definitely there is more change in kinetic energy. So kinetic energy change, so whatever kinetic energy change is there, that will also be more. Try to understand this. Okay, more work, I mean more force is there, more force is there means more work will be there. More work means more velocity means more change in kinetic energy. That is the meaning of it. Alright, fine, then let us take some of the numericals to understand this. A body's velocity changes from 10 meter per second to 20 meter per second. Find work done on the body if its mass is 2 kg. So what is the mass of the body? Mass of the body is 2 kg. What is the initial velocity? Initial velocity is 10 meter per second. What is the final velocity? Final velocity is 20 meter per second. Now they are asking us, I mean its velocity is changing from 10 to 20 means, so what is the work done? So what is the formula for work done? Work done is equal to final kinetic energy minus initial kinetic energy. That's it. And in this also if you want you can take half common and m also common. What remains inside, that is like v square minus u square. You can do it like this also. Just substitute all these values, that is half into m means 2 kg, okay, bracket v square is 20 square minus u square is 10 square. Alright, so what will be this work done? 2 and 2 they get cancelled and 1 is there outside. So we are left with only 20 square minus 10 square. 20 square is 400, 10 square is 100. So therefore the work done is 300 joule. That's it. Alright, so this was quite a simple case, no? Now in work, have we used force into displacement? No, I mean we haven't used them, but they will be coming indirectly here. But new formula what we have got is final kinetic energy minus initial kinetic energy. Alright, moving forward. Now this work is positive, okay? In the next situation we are getting negative work here. I'll show you that also. The velocity of a car changes from 20 meter per second to 10 meter per second. I mean the velocity is decreasing means definitely they must have applied the brakes, no? That's very important situation here. The velocity is decreasing, so brakes must have been applied. Now they are asking us to find work done on the body if its mass is 2 kg. Same situation, but here the velocity is decreasing. But here what was happening here, the velocity was increasing, 10 to 20 it has become. Alright, let us see this situation here. Now what is the mass of the body? Mass of the body is as usual 2 kg. Okay, what is the initial velocity? Initial velocity is 20 meter per second. What is the final velocity? Final velocity is 10 meter per second. Now what is the work done? Work done is equal to final kinetic energy minus initial kinetic energy. You know this. Alright, again half m is taken common and v square minus u square. Substitute that. 1 by 2 into m means 2, and in bracket v square is 10 square, u square is 20 square, 2 get cancelled, and work done is equal to, it becomes 100 minus 400, that is equal to minus 300 joule. In the first video already we have talked about negative work. What is the meaning of negative work? Look at this. Now this body was there, it was moving with what velocity? 20 meter per second. Now afterwards the body's velocity has become 10 meter per second, means the force would have been in the opposite direction. No? If the force would have been in the opposite direction, then only the velocity has decreased. Now the force is here and displacement of the body is in this direction. Look at this. What is the angle here? 180 degree. Both are in opposite direction. That's why this work is negative. Now consider that last situation. When you consider this last situation, the velocity has changed from 10 to 20. That means here was the body, it was moving with 10 meter per second, and after some time the velocity has become 20 meter per second, means what does it mean? Here the force would have been applied like this. No, now force is also in this direction and displacement is also in this direction. Both are in the same direction, means what is the angle between them? The angle between them is 0, and definitely work is going to be positive. Alright, I hope the inputs are clear now according to the situation also. Alright, fine then. What is the summary of all the things? First thing is like, in the first video we have seen work is equal to force into displacement. There is no doubt in it. Okay, this was from the first video, that is clear. Now in the second video we have mechanical energy. This mechanical energy is it has two types. One is potential energy, another is kinetic energy. Potential energy is due to position, okay, and configuration. Position and configuration. Configuration means how they are arranged. The spring is arranged in a particular way, right? The arrow and bow are arranged in a particular way, right? That is only known as configuration. And kinetic energy is due to motion. Alright, and third thing is kinetic energy is equal to, what is the formula? Kinetic energy formula is a half mv square. And the fourth one is what is the work done on a body? Work done on a body, already we have force into displacement. You can also take it as a final kinetic energy minus a initial kinetic energy. So these can be used. Alright, so this was the summary of these two videos. Alright, then take care, and in the next video I will come up with potential energy concept, and I will explain you in detail what is the concept of this potential energy. So be happy till then. Thank you very much. Have a good day, and bye bye.